Hello. For this particular lab, you're going to be needing a couple of components from your Adafruit Parts PAL kit. One of them is going to be a 560 ohm resistor, so that's this component here. And the color code for it is a green, blue, brown, gold. Again, I'll repeat it. It is a green, blue, brown, gold. You'll also need an LED, and really, honestly, it could be any of the colors that you have. But in this lab, it does actually state that it should be one that is green. But again, you can use any of the LEDs which you have there. You'll need a 9-volt battery. You'll need a meter as well. And you'll also need a couple of alligator clip type of leads like you see here with the alligator ends to them. Now what we're going to do is we're going to make a circuit, and this circuit is going to allow current to flow through the LED, causing it to turn on. So one of the things that we'll take a look here is at the battery. This is a 9-volt battery, and it does have a positive side and a negative side to it. And so with a lead, and granted I'm using a red one, which in most cases should be used on the positive side of the voltage source, but it's still just a wire. But I'm going to connect it to the positive side, and then the other end, I'm going to connect it to one end of the resistor. Now, the resistor is non-polarized, meaning that it does not have a positive or a negative side. So you could attach it to whichever side you want, and it'll be fine. Now, the other end of the resistor will need to have another alligator lead wire, and we're going to connect that one there, and we're going to connect the other end of this lead to the anode of the LED. Now if you look internally, hopefully you can see a short side, like a little stub right there, and then a big fat side. Well, the anode is typically going to be the short thin side. Another way to tell if the leads have not been cut is that you're going to have a lead that is longer than the other, and the positive side is that lead that is longer. So I'm going to connect this to the longer lead, making sure that it does not come in contact with the other lead right there. So I'm just going to spread it apart just a small amount right there. And then the other end of the LED will be connected to another alligator lead, and then that will be connected to the negative of the battery. Now, one of the things that you'll see, or hopefully see, is that when you connect it, the LED will now be powered up. It'll be on. So what the lab calls for then is to take a couple of readings. One of the readings, of course, is going to be using voltage. So on the meter here, you see that it's on a setting, okay, of 20 volts DC. This is basically a meter that you have to set the range of operation. So for the DC voltage, which looks just like this other one that has a V but it has a sine wave, that's for AC current. But we are here operating with DC voltage, with DC current. So from that perspective, we have to use this set of ranges. And the way that this works is that you need to set it on the range just higher or just above the voltage that you're trying to measure. You have such things as 0.2 volts, 2 volts, 20 volts, 200 volts, and 1000 volts. Since this is a 9-volt battery, I'm just going to set it to the 20-volt range. So therefore, all I'm saying is that the meter then can read all the way up to 20 volts. All right. If I set it down to the 2-volt range, it can only measure up to 2 volts, and then that's it. Anything above 2 volts, it'll error out. But you should always go ahead and pick the proper setting because it's going to give you the most accurate reading. So let me go ahead and turn it on. And so one of the things that we want to do is to measure the voltage across the battery. Now, just because it says 9 volts, it doesn't actually mean that you'll see exactly 9 volts. So we want to measure the voltage across the battery. And you can see here on the reading, it says 8.59 volts. So jot whatever you see, but on mine it's 8.59 volts. Then we're asked to measure the voltage across the resistor and across the LED. Now, one of the things that I need to explain here is that when we talk about conventional current flow, we're going to state that the current is flowing out of the positive side of the battery, And so therefore, the current's flowing out of the positive side is going to go through this red lead, and it's going to hit this side of the resistor first. That's where the positive lead of your meter should be. So we're going to place our positive lead here and the negative on the other side of the resistor. Now you can see that it's showing 6.51 volts. So that's the voltage drop, or that's the voltage across the resistor. Then we need to measure the voltage across the LED. Again, let's follow the current flow. If the current is flowing out of the positive of the battery and hitting the resistor here and then going through the resistor, then it's going to go through the green lead and it's going to hit this end or this lead of the LED first. So therefore, I'm going to measure with the red on that lead and with the black on the other side. And you can see that the meter shows 2.05 volts. Now, the interesting thing is what happens if you place the leads on the other side or in the other manner? Well, the only thing that will happen is that you'll get a negative reading. As you can see here, we get negative 2.04 volts, as opposed to if I place the red lead where the current hits first, you'll get a positive value. Now, the last thing that we need to do is to measure current. Now, to measure current, we need to break the circuit. Now, you can break the circuit anywhere you want. You can break it at the battery, all right? You can break it maybe perhaps at the top end of the resistor, or maybe here. You can open it up right there, or at the LED on either side. But we need to open it up in order to force the current to go through the meter and to be able to measure it. Now, so how do we prepare our meter here? Well, what we're going to have to do is to measure amperage. But the amperage in this right here in this circuit is going to be fairly small, so I'm going to set it to measure in the milliamp range. Now, one of the things is you see an insert here, so therefore I need to move the red lead to this other insert and push that all the way in. Now, the black lead, since that's a common lead, that always stays in that place. It never moves. Now, on the setting, on the range setting here, I need to change it over to DC amperage. You can see right here, it's an A, and it has that dashed with the solid line on top. That's for DC, as opposed to this amperage over here, which is AC because of the sine wave. Now, I anticipate that it probably will not go higher than 200 milliamps, so I'm going to set it at that range right here. And now, I'm ready to measure current. Now, the way that you know that the circuit is open is that when I open it up, the LED is going to turn off, because again, when you open it, current stops flowing, and you're going to bridge that opening with your meter, so therefore it's going to allow the current to flow through the meter, and I'm going to be able to measure it accurately. So one of the places that I can measure is perhaps the easiest point would be at the positive side. Open it up, and you can see that the LED turned off. Now, with that stated, since you can see that I opened it up right here, see, I can, right now it's closed and right now it's open. It's closed and open, so therefore it's open. And all I'm going to do is put my meter where it's opened up. I'm going to let the current flow through the meter and continue traveling out of the meter and complete the circuit. You can see that the LED has turned on. So that's an indication right there that everything is okay, all right? Because the LED will turn back on if the ammeter is connected correctly, but you have to open it. Any other which way, you'll probably damage the fuse inside of the meter, and it'll have to replace. So you can see that the current for me right now, the current flowing through the circuit is about 11.4 milliamps. And so we can reattach it, and we can measure the current at any other point as well. Say, for example, that I open it up at this junction here. I can open it up right here. You see, it's opened up. And all I'm going to do is put my ammeter and allow the current to flow through the meter. So the current's going to flow through the meter and out of the black lead and continue on its way. And you can see that the LED turned back on. And again, it's reading 11.3 milliamps, around there. All right. Now, I can measure it at the LED itself. Let's say, for example, I opened it up here. The LED turns off, of course, and the current's coming out of the green lead, and it's going to go through the meter, and then it's going to continue on its way, and there it is, okay? So I'm touching it, and you can see on the meter it's 11.3 milliamps. So no matter where you break it, the meter, the ammeter, is going to complete the circuit for you and measure the current. The current is the same at any opening. Wherever you break the circuit, the current reading should be the same at every point. All right, thank you.